All right, so we're in section 4.2. We're going to talk about the unit circle. All right, when we say unit circle, well, we know we're talking about a circle. So here's my circle. When we say unit, what are we talking about? What do we mean by unit circle? Journey? The radius is 1. So unit circle, radius equals 1. That makes some really nice things happen. So let me draw in a radius here. So there's my center, there's an angle, and I'm going to draw a little, I'm going to put the center of my unit circle here, and I'm going to draw this little triangle. Here's my angle theta. If I let this point be at 0, 0, right at the center of the circle, so if that's 0, 0, this distance on this side of the triangle is going to be x, whatever x happens to be, and this side of the triangle is going to be y, and our radius is 1. So this is how we're setting up our unit circle, and this lets some really nice things happen. How do we find the sine of an angle? And this, remember, this is a 90-degree angle. Yeah? Opposite over hypotenuse. So sine theta equals the opposite side, y. The hypotenuse is 1. So we get sine theta equals y. And the cosine theta? Adjacent over hypotenuse, x over 1, x. Well, this point up here on the circle is the point x, y. So the x-coordinate of this point is given by the cosine of the angle, and the y-coordinate is given by the sine of the angle. That's really what all there is to the unit circle, is finding these x and y coordinates and how they relate to this angle. We're going to add one other twist in just a second. And do we remember tangent theta? Opposite over adjacent. And then we have our cofunctions. The cofunction of sine is cosecant, is the reciprocal. And this is also on your note sheet. We're just kind of setting up what we're going to do with our note sheet. So we have a way of finding the sine and the cosine on our unit circle. The sine of the angle gives us the x-coordinate of this point. The cosine of the angle gives us the x-coordinate of the point. The sine of the angle gives us the y-coordinate. Well, what we want to do is figure out a way to, rather than talk about sines and cosines of angles, we don't want to restrict ourselves to just to talk about angles. So to get rid of that restriction, the idea is we're going to take our unit circle, same unit circle that we had before. The center here is at 0, 0, and out here at the end of where the circle intersects the x-axis, I'm going to attach a number line. So this point on the number line is 0 on my number line. I'm just sticking a positive number line on this unit circle. So I have 1, 2, 3, and then what we're going to do is take this number line and wrap it around the circle like it's made of flexible string. So each of these numbers on the number line hits a point on the circle. And that way we can associate this point on the circle with an angle, because we can associate this point is given by some angle on the unit circle. We can associate each of these numbers with an angle. That lets us talk about the sine and the cosine of just a number. not just the sine, not the sine and the cosine of an angle, but the sine and the cosine of 2.5. So we can associate the angle with a number, and we talk about the sine and the cosine of a number. So we're not restricting ourselves to angles. And each of these numbers, when I wrap it around, gives us a point on the unit circle. So I have a little animation that shows that. So here's my number line. They've drawn the number line straight up. So we've attached this number line to the circle. And we're going to see if that's going to cooperate. It was going really slow before. So we're going to wrap that number line around the unit circle. So I've taken that number line, wrapped it around the circle there. Based on what we talked about the last few days, what does this 3 correspond to? 3 what? Someone said it? Radians. That's 3 radians. Our radius is 1. This is 1 unit. There's 1 radian, 2 radians, 3 radians. Let me see if I can get it to wrap a little bit further around. I went backwards. There we go. There's 5 radians, and I went backwards again. This program is pretty, there we go. There's 6 radians. You said there were about 6 radians in a circle. So there's my 6 radians. There's 3 radians, 4 radians. So we're associating those numbers on the number line with an angle on the unit circle, and each one of these points has an x and a y coordinate. So that's what we're doing with the unit circle. The unit circle lets us take the sine and the cosine. Think about the sine and the cosine of a real number, not just an angle. Doesn't necessarily have to do with triangles. It has to do with this circle and the angles in the circle. The angles in the circle have to do with triangles. So we take this number and we associate it with the circle. So that's our setup for what we're going to do with the unit circle. So now let's look at your note sheet. So we're taking that number line and we're wrapping. Let me see if I can get it to autoplay. So it'll wrap it around a few times. There we go. And so it just keeps going. All the numbers just get wrapped around the unit circle. And each one is associated with a point on the circle and with an angle. So that's our setup. All right. So let's go back here. And let me grab a page, that first page of the note sheet, and we'll start in on this. And I'm going to make this a little smaller because I'm going to do kind of 2 things at once here. So this is exactly like what's on the bottom of your radian, the snowman. So I'm going to we'll fill in part of this together while we talk about the other part of the unit circle. So what we're going to do to make the unit circle user friendly is we are going to use these special right triangles, 30, 60, 90 triangle and a 45, 45, 90 triangle. When the hypotenuse is 1, on a 30, 60, 90 triangle, the short side is 1/2 and the long side is the square root of 3 over 2. It's always going to work that way with a 30, 60, 90 triangle. 45, 45, 90 triangle, if the hypotenuse is 1, the 2 legs are going to be the square root of 2 over 2 units long. And that lets us mark off these special angles on the unit circle and figure out the x and the y coordinates of the point. The x and the y coordinates give us the cosine and the sine of the angle. That's what's really nice about the unit circle. The x and the y coordinates on the unit circle give us the cosine and the sine of the angle from what we just talked about before. And that's what this little drawing is showing us. Our radius is 1. This side is x. That side is y. The x is the cosine of the angle, and the y is the sine of the angle. So let's put in some of these special right triangles onto this unit circle. So you could start filling in your radian the snowman, this first quadrant of your radian the snowman, from unit circle. So let's do this first angle. And you don't have to fill yours in exactly like I do mine. Some people have preferences on as to how they do it. So this first angle is this 30, 60, 90 triangle. The angle is 30 degrees. We want to start thinking in radians. So 30 degrees is how many radians? Pi over 6. So this is going to be pi over 6 radians. And we want the x and the y coordinates of this point. So how long is the long side of my 30, 60, 90 triangle? Square root of 3 over 2. How long is the short side of my 30, 60, 90 triangle? 1/2. The cosine of 30 degrees is the square root of 3 over 2. The sine of 30 degrees is 1/2. Right triangles with the same angle are always similar. So no matter how big or small the triangle is, the sine of 30 degrees or pi over 6 is 1/2. The cosine is square root of 3 over 2. We know the sine and the cosine of this angle because we can figure out this coordinates on the unit circle. Let's do the next one. This one's going to be our 45, 45, 90 triangle. 45 degrees is how many radians? Pi over 4. And how long are both sides of my triangle? Square root of 2 over 2. The cosine of 45 degrees, or pi over 4 radians, the square root of 2 over 2. The sine of 45 degrees, or pi over 4 radians, the square root of 2 over 2. The x gives us the cosine of the angle. The y coordinate gives us the sine of the angle. Let's put in this next angle. This is a 30, 60, 90 triangle turned the other way. So now I have the 60 degree angle here. 60 degrees in radians. Pi over 3. And how long is the short side, the x coordinate? Short side is 1/2. The long side, square root of 3 over 2. The cosine of 60 degrees, or pi over 3, is 1/2. The sine of 60 degrees is square root of 3 over 2. Let's go up here to 90 degrees. How many radians is 90 degrees? Pi over 2. X coordinate here at 90 degrees. What's my x coordinate? 0. Very nice. Y coordinate on the unit circle? 1. There's the first quadrant of the unit circle. This tells us the sine and the cosine of pi over 6, pi over 4, pi over 3, and pi over 2. We know the sine and the cosine of those angles because these special right triangles with hypotenuse 1 fit right in the unit circle, and I can figure out the x coordinate, the y coordinate, the cosine, and the sine of that angle. Now let's continue. Let's do one more. So I'm going to go around, and then you guys can fill in the rest of your radian the snowman. We're going to go around here. Remember, our angle is measured from the positive x-axis. So what would this angle be in degrees? Okay, 2 pi over 3 is good. 120 degrees. And I'm going to project this down. This is a 30, 60, 90 triangle. Short side, how long is the short side? 1/2, and we're going this direction, so negative 1/2 since we're going to the left, and the long side, square root of 3 over 2. The cosine of 120 degrees, or 2 pi over 3, is negative 1/2. The sine is square root of 3 over 2. And we can continue going around our unit circle, filling in just by laying these special right triangles onto our unit circle. That will let us know the sines and the cosines of all of these angles on the unit circle, just by realizing that there are those triangles, those special right triangles laying on that unit circle. So that's how we make up the unit circle, by putting those triangles on the unit circle. And that lets us figure out the sine and the cosine of every single one of those angles. Once we know the sine and the cosine, we can find the tangent, the cosecant, the secant, and the cotangent. So we know all of the trig functions. We'll know all of the trig functions of all of those angles on the unit circle. So that's what the unit circle does for us. It lets us think about these special angles. It lets us figure out the sines and the cosines by relating them to these special right triangles. So part of what you need to do is finish out your Radian the Snowman. And you can decorate Radian the Snowman, make it look nice. I had lots of nice Radian the Snowman last year. These will help you. Your unit circles will help you as you do your homework. Eventually, you will have the entire unit circle memorized. And in fact, at one point we'll do a quiz. I'll give you a blank unit circle that looks like this blank thing that I put up there, and the quiz will be to fill it in correctly, the entire thing, in radians, from memory. The test that we'll do, I think we have maybe one quiz, maybe on one test. I give you a unit circle, and then I just put a blank one on the test for you. You can fill it out on your own from memory if you need it. But you will remember these angles and these sines and the cosines of the unit circle. We'll do it from memory. So this is how we construct the unit circle, by putting these special right triangles on the circle radius 1. Lets us figure out the x and the y coordinates, which give us the cosine and the sine of our angle, and that also lets us relate a real number, because we've wrapped the number line around our unit circle. We can find the sine and the cosine of just a real number. Yes? Yes. So what I just drew here, that's how you would fill out your unit circle for the entire thing. So cosine and sine, and that's just the x and the y coordinates. My students last year told me the unit circle quiz was the easiest quiz of the semester, and I think the average was like 95%, because you know what's on it, you know all the answers. All you have to do is put them in the right place. All right, questions on how we set up the unit circle. So what the unit circle is going to let us do is, when we're doing trigonometry, when we're finding sines and cosines of these various angles, we can use these numbers and not have to plug everything into our calculator. We can calculate with these numbers. We have a group of angles that we know the sines and cosines for, so that lets us work with these angles more easily. All right, let's look at another part of your note sheet. Let's look at that chart that is right below this piece. So let me grab that and I'll put it on another page. There it is. So here's our chart. If it helps you to fill out this chart, now there's a chart on the back side. We'll do a couple of these on the back side. But then part of what you need to do is at least the sines and the cosines, but I would recommend doing the others. is fill out this chart for all the different angles once you get your radian the snowman figured out. But once you know the x and the y coordinates, this chart is really easy to fill out. So if it helps you, you can say the sine, and that's y. The cosine is x. The tangent, y over x. The cotangent, x over y. The secant, 1 over x. And the cosecant, 1 over y. So 0 radians is 0 degrees. What's the y coordinate at 0 degrees? I'm right here. What's my y coordinate? How far up and down am I if I'm right here? 0. 0. Cosine. If I'm out here at 0 degrees, what's the x coordinate? 1. Because my radius is 1. Tangent. Y over x. 0. Cotangent, x over y. 1 over 0 is undefined. Secant, 1 over x is 1. Cosecant, 1 over y, undefined. Pi over 2 in degrees, 90. What's the y coordinate at a 90 degree angle on my unit circle? 1. X coordinate, 0. Tangent, y over x, 1. Cotangent, x over is this y over x? Y over x? No. Tangent's going to be undefined. 1 over 0 is undefined. X over y is going to be 1. No. X over y is going to be 0. Secant. 1 over x, undefined. Cosecant, 1 over y, finally, a 1. I've been wanting to put that 1 in there the entire way. Pi, 180 degrees. What's the y coordinate at 180 degrees? 0. The x coordinate, -1. I'm over here at pi, so you could fill that in on your radian the snowman. That's 180 degrees. That's pi. My coordinate is -1 and 0. So that would be on your unit circle. -1 and 0. The tangent, y over x, 0. The cotangent is going to be undefined. 1 over x, -1, and 1 over y is going to be undefined. 3 pi over 2, 270 degrees. So that's one that we hadn't filled in on our unit circle. Sine, what's the y coordinate at 270 degrees? -1. The x coordinate, 0. Y over x, undefined. X over y, 0. 1 over x, undefined. And 1 over y, -1. So there's our trig functions for all of our, what we call our quadrantal angles. The quadrant angles. Then on the back side, it has a place for all of the other angles that you'll fill in on the unit circle. So let's go through at least one of those to help you out. We already did most of these for the first quadrant. So let me grab the picture of that. Here we are. So I'm going to grab that, put that in the So we did pi over 2 on the first side, so you can transfer that over. We did 0 on the first side, so let's do pi over 6. How many radians is pi over 6, or how many degrees? 30. The sine, the y coordinate. The short side of the 30, 60, 90 triangle.
3 over 2.
1/2. The short side's 1/2. Square root of 3 is about 1.7, so square root of 3 is bigger than 1. So this is going to be 1/2. The x-coordinate? Square root of 3 over 2. The tangent, remember this is y, x, y over x, x over y, 1 over x and 1 over y. Tangent y over x, 1/2 divided by the square root of 3 over 2. So let's look at that. When I divide fractions, what do? Multiply by the reciprocal. So the 2's cancel and I get 1 over square root of 3. And when I have a radical in the denominator, I want to rationalize. Tangent of pi over 6 is square root of 3 over 3. Cotangent, x over y, or the reciprocal of tangent, is going to be 3 over square root of 3. And I want to rationalize that. And I get square root of 3. Secant, 1 over x, 2 over square root of 3. I'll rationalize that to 2 square root of 3 over 3. Multiply by square root of 3 over square root of 3. Yes? I just multiply the numerator and denominator by whatever the radical is in the denominator. Okay? What's that? More than one radical. So in the unit circle, we'll never have more than one radical. If you have more than one radical, then you multiply by the conjugate. And then cosecant 1 over y, 2. And pi over 4 we said is 45 degrees. We already filled this out. The sine, square root of 2 over 2. Tangent, what's our tangent going to be? Y over x. Square root of 2 over 2 divided by square root of 2 over 2. 1. X over y. Square root of 2 over 2 divided by square root of 2 over 2. 1. Secant is 1 over x, or 2 over square root of 2, and I'm going to rationalize that. 2 over square root of 2 times square root of 2 over square root of 2. And I get 2 square root of 2 divided by 2. Those cancel, and I get square root of 2. And cosecant square root of 2, 1 over y is the same. So there are all my trig functions for 2 of my first quadrant angles. We did the x's and the y's for the pi over 3. And you can go through and do the tangent, cotangent, secant, cosecant. So what I would recommend is that you at least go through and do your sines and cosines for all of these angles, and maybe your tangents. But you do need to know how to find your tangent, your cotangent, your secant, and cosecant from the information that you can get from the unit circle. And the unit circle tells us the cosine and the sine of those angles, the x-coordinate and the y-coordinate of those angles. All right, questions on how we set up this unit circle? So again, part of what you need to do, make sure you fill in your radian the snowman so you have your unit circle filled in. This is really the same information in just kind of a tabular form, and then you can get your other trig functions, your tangent, cotangent, etc., but you can always figure them out by using these pieces. Tangent is y over x, cotangent is x over y, and so on. And we can also think of, let me go back here really quickly. We can also think of the tangent. Tangent is y over x. that also equals sine theta over cosine theta. 1 over y is 1 over sine theta, 1 over x is 1 over cosine theta, and this is cosine theta over sine theta. These are all, 1 over y is the same as saying 1 over sine theta on the unit circle. So these are all the same. You can think of them that way also. All right. In your homework, it will ask you questions like this. Evaluate the 6 trig functions. At the real number pi over 3. What this is asking you is to find the sine, the cosine, the tangent, the cotangent, the secant, and the cosecant of pi over 3. Pi over 3 is our unit circle angle. On the unit circle, what are our coordinates that we associated with pi over 3? One half and square root of 3 over 2. That's cosine of pi over 3. That's sine of pi over 3. That's my x and that's my y. Once I know that point on the unit circle, then I can get exact answers for all 6 of my trig functions. So I do what we did, the example that we did on this chart. Tangent is y over x. Cotangent is x over y. Secant is 1 over x. Sorry, 1 over y. Cosecant is 1 over x. And you do that for this number. It'll ask you for the exact answer, or don't use a calculator. That means you're using the unit circle to come up with these numbers. And you're rationalizing the denominator or whatever you need to do like I did on that chart. All right, questions? Okay, we will be talking about the unit circle a lot over the course of the semester. Like I said, we'll work on memorizing it, getting these angles memorized. There are lots of schemes for memorizing how the numbers on the unit circle work, this and that. I think it is more valuable to think about those triangles on the unit circle, the short side, the long side. Which kind of triangle is it? How long is the long side? How long is the short side? Where is it sitting on the unit circle? And then you don't have to memorize some kind of scheme. You just know how 2 different triangles work. All right, here it comes. We'll work some more with the unit circle tomorrow. All right, there you go.